Look, these first questions here, we're looking where f dash x equals 0, so where the gradient is equal to 0. So if you look at the function, the gradient is going to be 0 at any turning point or stationary point. So if we look at the graph here, you see that there is going to be a point of 0 gradient when x is equal to -3, at 2, and at 7. Okay, so that'll be these values here. Alright, so where the derivative is less than 0, so where the gradient's less than 0, so we're looking at this section here. Okay, so this section here is going to be -infinity up to -3. We do not include -3 because the gradient is 0 there. Or you see the other section that we have here where it's a negative gradient is going to be from 2 to 7. Not including these values because we know that that's where the gradient is 0 there. Sections where the gradient's going to be positive. So you'll see here we have a positive gradient in this section here. So that's going to be from -3 up to 2. Again, not including. Okay, or you see that the final section here is going to be from 7, not including, up to infinity. So in this question here, state where f is strictly increasing. So when it asks where it's strictly increasing, basically where the gradient is positive. So it's going to be similar to C, but the key word here is strictly. So when it says strictly, you actually include the points of 0 gradient. So the answer for this question is going to be from -3 to 2, and it will be including, or 7 to infinity. Obviously, we never include infinity. Okay, so strictly increasing means that you do include the points of 0 gradient. And then for E, so strictly decreasing, and it's basically where the gradient negative, but again, including these points of 0 gradient. So it was from -infinity to -3, which we include, or, and then we'll say 2 to 7, and we include both of those points. So f's the value of d for which this function, so if we're adding on f of x plus d, so it's outside the function, you're either moving it up or down. So if you're going to move it down, you see you always have 2 solutions at least. Okay, so if you move it down 2, you would still have 4 solutions, you know. If you moved it down 4, you see you'd have 3 solutions, 1, 2, 3. If you move it down more than 4, then you would have 2 solutions, and moving it down, you always have 2 solutions. So the only way that we're going to get no solutions is to shift it up the way. So if we shift it up, you see -6 here. So we'll move it up 6 rather. Okay, then this would sit in the axis. You'd have 1, 2, 3 solutions. If you moved it up, say 10, you'd have 2 solutions. If you moved it up 14, you would have 1 solution. So basically, to have no solutions, you just move it up further than 14. So and therefore, D would have to be greater than 14. And the same idea here. Okay, so I've labeled these wrong, but so we went through the 2 solutions. So basically, if we move it down 4, then you're going to get 3 solutions. Move it any more than 4 down, then we're going to get 2 solutions. So D, I think it's C in this case, isn't it? So we'll have C's got to be less than -4. That'll be moving it. Or C, if we think about moving it up again. So this would also be 2 solutions, you see. So here, between these 2 points, if you moved it up between 14 and 6, you're going to get 2 solutions as well. Okay, so 6 and 14, but not including, because if you moved it up 6, then you'd have 3 solutions. Okay, so when you moved it up 14, you'd only have 1 solution, so therefore it's going to be between 6 and 14.